Adaptable, extending reach over large tabletops through flexible multi-display configuration. Techniques for extending user reach in tabletops. Interactive tabletops are beneficial for exploratory and interactive visualization tasks. However, in large tabletops, regions far from users can be hard to access. Adaptable. We propose AdapTable, a flexibly reconfigurable, multi-display tabletop that can adapt its shape in ways that extend users' reach by self-actuated display sliding. The system supports flexible multi-display configuration with its 4 horizontal screens. From the central merged position, a menu offers system reconfiguration into the layouts: slide, left single slide, right single slide, or split. Screen layout study. In this study, we investigated 1. When will users prefer to change table layout? 2. Can flexible table layout help reduce physical demand and frustration levels? And 3. Which table layouts are preferred by users? To investigate these questions, we prepared 7 task scenarios, 2 tasks, and 2 layout situations. There were 7 different target distribution scenarios as seen from a user perspective. Green areas offered contents triggering more interaction. Yellow areas offered contents triggering less interaction. We retained the 5 most preferred scenarios and discarded 2. In a group study on merged and flexible situations, we presented a reaching task and a docking task. During the merged situation, participants couldn't change the table layout. During the flexible situation, participants could change the table layout. Here we see the 3 most preferred table layouts, above for reaching, below for docking. From this study, we found 4 screen layouts, merged, slide, single slide, and split, to be preferred by users to minimize physical demand and frustration levels. Prototyping of AdapTable. The AdapTable system consists of 4 touchscreens, each equipped with a Roomba robot for display sliding. An infrared motion capture system was used both in the screen control study and later on in the comparative evaluation. Secondly, we explored alternative ways of controlling the multi-display layout to design AdapTable. We examined a touch menu, touch gesture, and user position. The touch menu was clearly preferred. Comparative evaluation. Finally, we conducted a study comparing AdapTable with a conventional panning technique. The tasks studied were a flag task and a number task. Both required reaching and docking and gave significant results. For 2 scenarios, left, vertical, and large, AdapTable showed lower task completion time than panning. For the number task, AdapTable showed lower frustration levels than panning. In 4 of the 5 scenarios, AdapTable was preferred over panning. Results. Our results show that for several target distribution scenarios and typical task categories, AdapTable can offer more efficient and effortless interactions by extending users' physical reach. More results can be found in our paper.